thought I should do an update on where I'm at with this 3D printed Enigma machine. I've made a fair bit of progress since last time, just fixing up some of the mistakes and increasing the rigidity in the machine. I actually have it at the point now where operating the this plate that the keys press on actually steps the machine round. It's a little bit noisy in here because I'm actually printing another piece at the moment, but this piece here is what the keys press down on. So they're the 3 rows of keys that press down on this piece, and it's pivoted through the middle here. And also normally there are springs that are pulling this back up. I don't have the springs in place yet because I don't have the rest of the mechanism there. So normally this sits in the up position like that. What happens is when a key goes down, it of course steps the rotors round. So we can see that working now. And you can see the rightmost, what's called the fast rotor, this one here, moves around every time you press down on a key. And then at a certain point it will also move the second one round, and that's coming up in a couple of clicks. So you can see the second one went round then. To get this to work, you can see when it's moving, it might be a bit hard to see on the video, there's a little bit of flex in the mechanism still. You can see this is moving around. And that was one of the problems I had last time, was making all of this rigid enough. So what I've actually done is, if the camera will focus, I've reprinted these side pieces and made them a lot more rigid by printing these bosses onto them. The other thing you can see I've done is I've actually started printing the base. I was going to print the base all in one big piece, but it was going to be a huge print and take days to do. So I'm actually going to do it in sections. And what I have here is the main base that holds these side pieces that take the rotor stack, and the axle for the plate that the keyboard moves up and down, the keys press up and down on, because the spacing, the relationship between this piece and the rotors and the mechanism that engages the rotors is critical. So that keeps all the spacing accurate. You can see, if we have a look at, originally I had the side pieces like this, they were just flat. And these are 2.5 millimeters thick, and I'm printing everything very densely. It's one of the reasons why all my prints take so long, is because I'm printing with very, very thick shell sizes and very dense infill. We can have a look at that on the piece I'm printing at the moment. But even printed thick like this, the pieces have quite a bit of flex to them. So you can see there's quite a bit of bend in that. So what I did is I redesigned everything and added these bosses, which just increases the rigidity a huge amount. So the pieces are now a lot more stiff. And so hopefully the mechanism won't flex too much. We'll see how that goes. I may need to strengthen things up some more. I've also modified a little bit from the original Enigma design how the pieces are mounted so that it's easier with 3D printing. Printed these little corner pieces. Everything's bolted together to hold it all in place. I think before, in the last film I did, you could see I was having problems with flex in this bar. And this bar is what's holding these little springy arms. And these arms are what are running in the little scallops on the edge of the rotors. And you can see as the rotor clicks round, that's what maintains the stepping, the positioning of each rotor, so that's got a definite position. That's what gives you that clicking. I did have a problem. You can see I've still got the problem a little bit of, there's a little bit of racking in this piece. What I did is I printed these pieces to be thicker so that there should be less movement, and that's helped a lot. And I think eventually what I'll probably do is actually glue these bars in so that this piece doesn't twist. So you can see I've beefed up the other side as well, and that's to remove a lot of the flex in the mechanism. So what we can see as well, it's a bit tricky to see. I'll take some close-up photos and post them on my my website. But you can see down in the base here are the springs that are pressing against these little arms. So they're sprung loaded. And it's very hard to see, but inside here are the 3 pawls which are engaging on the ratchets on the rotor wheels. So I'll, if we can, I might be able to zoom in a bit. Let's see if that helps. I'm not sure if the camera is actually able to focus, but it's probably a little bit blurry. But inside here you can see one of the pawls. And so as the keyboard goes up and down, you can see that pushing the rotor around. It's very difficult to see. And this also shows how the movement is transmitted from one to another. Inside here, you can see the second pawl along, this one here, is actually running along the edge of this ring on the rotor. And at a certain point, which it's at now, you can see there is a notch inside there on the edge of the rotor. And so that pawl now drops into that notch, which lets it move further forwards, which is what allows it to then engage in the rotor on the next, the ratchet on the rotor next over. So now it will do the step of the second rotor. You can see it pushes both of them around. Again, I'll take some close-up photos of this, showing how it works. You can see that the pawls have a, as the keyboard piece comes up, they drop further back, and that's because of some little pieces that are in the base here that the pawl levers actually sit on in the most upright position, and that's what keeps them far enough away from the rotors that they don't engage all the time. So what we can do is we shift this a bit. So what you can see here, this is the lever that releases the rotor stack. So that comes back, that disengages these springy pieces off the rotors, and it disengages the reflector, which can now slide back, and then you can pull out the rotor stack. So with that out of the way, we might be able to see how the pawls work. So you can see all 3 of them move at the same time and can engage with the ratchets on the rotor here. They push around on those. So normally on the real machine, these are actually sprung. There's little coil springs that go around these, which are there to pull the rotors, pull the pawls forward into the rotors. And I didn't want to actually have to make all those little springs and things, so I've cheated. And what I've done is I've redesigned the pawls to have these brass weights on them. And basically the weights, because the pawls pivoted through the middle there, these little weights just cause them to fall forwards the whole time. So basically gravity is what's letting the pawls engage with the rotors. Obviously in the real machine it had to operate in all sorts of different conditions and on the back of military trucks and things like that, so they wanted positive location. For my machine, which is just going to sit on a desktop, you know, this actually works fine, and it was much easier to build. So I didn't have to worry about springs and trying to get spring tensions right, and you know, the problems of small springs trying to fit into fairly inaccurate plastic parts and things. So that's actually working quite well. You can also see, if I can find something to point with, scalpel, that'll do. Underneath here, so you can see the pawls lift up and down, and under here there's a little piece I call a buffer, and it's just a little stand. And what happens is as the keyboard comes up, the pawls ride on the edge of these little buffers, and that's what's lifting them up and back. So that's what lifts them all the way up out of the way. These are just printed parts bolted into the base. But you can see how these move, and if the rotor isn't in the right position to turn around, the pawl just rubs on the edge, it doesn't push it round. You can see they move independently. If we move the little lever, you'll be able to see how the reflector just comes out completely. Has the little ramps on the back of it. These bits here, that these little bumps on the lever push against. So the reflector slides in there. This little bar just stops it from rotating. So it fits in there. So that can slide backwards and forwards, but it can't rotate. And you can see as the lever moves forwards, it pushes this forward, and it also brings these forwards to engage in the edge of the rotor. So you can see as it comes back, they go back. And so we can put the stack back in, which is a little bit awkward, especially because I don't have the springs to hold the keyboard out of the way. So normally, of course, the keyboard part is pulled up. Now, you can see the stepping working again there. I'll see if I can refocus the camera and we'll get a closer look at how that works. Okay, we'll see if we can get some close-up looks at how the pawls actually make the rotors move. So this is the fast wheel here. This is the rightmost one. And you can see as you press down on the keyboard part, it causes the pawls there lift off their little bases, and so come in to engage the rotor. And of course the rotor is held in a particular position by the little wheel here. So you can see that holds it in a fixed position. So then what happens is, as you press the key, it comes forwards and engages. And then as you go down, it because it's like a seesaw, pushes it up and then comes back out of the way. So that's the basic mechanism for moving it around one letter at a time. Now the next bit is where it starts getting a bit trickier. So you can see as you press down, all three pawls always move at the same time, because they're linked on a common shaft at the bottom there. And so the reason why the second and the third wheels aren't rotating is because the pawls on those, I can find my pointer again, in here you can see, if I can get in there, this pawl is thicker. The first one is quite thin, because it only has to engage the first ratchet. The second and third ones along are much fatter, and they're actually bridging between rotors. And you can see this left hand edge here rides on this edge of the rotor. And so you can see when the key goes up and down, because it's the left hand edge is riding on the edge of that rotor, it can't fall forwards and engage the next ratchet along. It keeps it away from it. Now when it's in the notch position, which it's in now, and you can see at the moment the letter Q is the one that's at the top. This is where that the mnemonic that Bletchley Park used to use to know where the turnover positions on each of the rotors is. And so there are 5 rotors, and they used to use the saying, royal flags wave, kings above. I think that's it, which never actually seems to make a lot of sense to me, but that explains what letter shows in the little window at the top of the machine just after the rotor has stepped around. So we can see it's just about to step. It's sitting on Q. R would be the next letter to be seen. And if we look in the back here, you can see the pawl can now drop into the little notch in the rotor. Which, if I grab one of my other rotors, you can see this is the little notch there. So you can see how the rotor fits in the machine like that, and there's the notch. So when it's in that notch position, it can drop in and move the second rotor around. So that's what happened just there. And you can see now it's not going to engage again because it can't, the notch has moved. And this explains why you see the famous double step. And we can sort of show that if we get the second rotor. It's a bit tricky. So let me rotate these around to there. So if we step around now, the first one goes round, and then the second one is going to go round, and it's brought the middle one into the position where the next time it goes round, it drops into its notch, and you can see it's dropped into the notch there. So now when we click over again, the middle one has actually stepped twice as it's taken the third one with it. So that's why you get that double stepping. It's just a mechanical thing, and it's the fact that when a rotor falls into its notch position like there, as it goes down, it's making this one step and this one step. So every time you're in a notch position, two rotors are moving. And of course you only notice it on the middle one because the fast rotor is always moving anyway. It's not like it's going to be pulled around when this is in its notch position because it's being moved by its own pawl. And the slowest rotor doesn't have a rotor to its left if you're looking from the front of the machine. So it's never going to double step. So it's only the middle one that ever does that. You can see. Basically we set that up again. So, and you can try this on the Enigma simulators that are around. If you use rotor order, I've kind of got this backwards really. So you have to look at it. This is rotor 1, rotor 2 and rotor 3. So you set it up so that you've got, say, Q on the fast rotor, D on the middle rotor, and it doesn't matter what you have on the third one. And so now when we step, you'll see the first one go round and the second one, and now you should see all three go round. And that's because of that double stepping. So yeah, that's kind of how it's working at the moment. So this is enough to show me that the basic mechanism is going to work. What I need to do now is actually start building the keyboard part. So the keys press down on this. One interesting thing to note, and I had someone confirm this on a real Enigma machine for me, is that because this is a seesaw, and of course the pivot point is here, and you've got 3 rows of keys, because this is moving up and down in an arc, the keys on the bottom row have to move further than the keys in the middle and the top rows. So the keys on the keyboard actually move down different amounts, depending on which row they are, because they have to push this down different distances to get the same amount of stepping. So that's the next job, is start designing the keyboard. The lamp board is just to hold the lamps. There's no mechanical interaction with it there. One of the tricky things with the Enigma is the way it works is the rotors move and then it sends the current round. So normally this would be up. You press a key, the key goes down, moves the rotor, and then it sends the current through the machine. It's quite an important little distinction, that. So it means I'm going to have to set the keys up so that they first move this, and then they engage the little switches that send the current around the machine. So that should be interesting. I did think of a way you could cheat with that, where you as soon as you press the key, it sort of makes the circuit, but you have another switch that only engages when the keyboard's all the way down. You could maybe do it that way, but I'll have a go at designing it and see how it comes out. But I'm pleased with it so far. The other thing, of course, I need to do is all the electrical stuff, and it's going to be very interesting to see, once I've got all these little contacts and pins and things, how freely this will move. I'm quite worried it'll all sort of bind up. It might not be free enough to actually rotate, but we'll see. Worst comes to worst, I've still got like a nice mechanical model of a Enigma machine at the end of it. You can see the stepping there. Obviously has to go around 26 times, but you'll see as the R comes around, the middle one should step. There you go. It would be very interesting to actually one day play with a real Enigma machine to get the feel of it. It's kind of hard to explain, but you know, my plastic model, it's very mechanical feeling because it is a mechanical thing. When you get round to that step around point, it actually takes quite a bit more force to get it to actually step. Not a huge amount more, but it's noticeable that it's doing more work. It'd be interesting to see if on a real machine with all its nice precision made parts, if you feel that same difference. So yeah, that's where I'm at now. So just some little close-up details. This is the second rotor along. You can see the first rotor there. You can see how the pawl comes in and engages. And you can see this is the second rotor, and that's in its notch position. And if you look at the third rotor, you can see it's not in the notch position, so it rides on the edge of the rotor and doesn't engage. So if we step round now, you can see how that works. So this should be a closer view of how the double stepping works. You can see this is just the first rotor moving around. And again. And if we look on the top now, we can see it's in position, rotor 1 is in Q and rotor 2 is in D. So if we go back to the back of the machine, and we should be able to see, as it comes in now, the first rotor and the second rotor should move. And then now as the keyboard comes back up, you'll notice that rightmost pawl then drops into its notch. We press the next letter down, and then all three should move. And that's what's meant by that double step. That middle rotor moved on two subsequent key presses. And this is just to show what the noise in the background was. I'm reprinting the keyboard piece, just with a few minor changes. This is quite a big print, so this takes 28 hours or so. And one of the reasons it takes so long is, one, my print is fairly slow, but two, I'm printing at a very high density to make the parts quite rigid. So you can sort of see the infill pattern there is quite dense. And it just takes it a long time to print. So that's what's happening there.